5.6, we are simplifying what we call complex fractions. So there's no solving in this one. We're just simplifying. And complex fractions are not pretty at first, but you'll know when you see one. Always. Okay? Well, these are fractions in fractions. That's what makes them complex. Yeah. Yeah. It's okay. It's not as bad as you think. So we have 3 steps to simplifying these. Step 1, we want to try and cancel out those fractions because we have a fraction in a fraction. So we're going to multiply the numerator and the denominator by the lowest common denominator, the LCD, and reduce those to get rid of the fractions. Now remember, we need to multiply the top and the bottom. Okay, step 2, we are going to combine like terms on the numerator and the denominator if we can. And then step 3, we're going to simplify. Alright, so example 1, this is what I mean by it's ugly. That does not look very friendly. I know. I know. Okay. Alright, so the reason why we don't like this is because we have x over 2 minus 1 all over 1/2 minus 1 over x. That's a fraction within a fraction. So what we want to try and do is we want to get rid of the fractions. So we're going to multiply the numerator and the denominator, and I put them in parentheses so we keep them together, by the lowest common denominator. Can someone tell me what would the lowest common denominator be? Brandon.
X over 1.
Not x over 1.
X over...
We need to get something that all of these have in common. Ashley, do you know what it is?
1 over 2.
No, it's not a fraction, guys.
1, 2.
The negative sign. X minus 2.
What do you think, Diego?
2.
Not just x by itself. Does 2 go into x? What did you say, Brandon?
2x.
2x. 2 goes into 2x, and 2 goes into x, and x goes into 2x. So we're going to multiply the numerator by 2x, and we're going to multiply the denominator by 2x. Okay? What property does this look like? Distributive. So distribute. Okay. So what will I have in the numerator? If I have 2x times x over 2.
2x to y.
2x squared over 2. So what's going to happen with those 2's? Okay, let's look at it. Let's multiply it all out. This is going to be 2x squared over 2 minus 2x times 1? 2x. All over 2x times 1 over 2 gives me 2x over 2 minus 2x times 1, 2x over x. Is everybody okay with this so far? All I did was distribute, and I'm multiplying the numerators. Why would the bottom be 2x? We are not trying to get a common denominator. We are trying to cancel these fractions. So let's look at what we have. 2x squared over 2, what happens? Those 2's cancel. What about down here? What cancels? The 2's and these x's. So what do we actually have? X squared minus 2x in the numerator all over x minus 2 in the denominator. Okay, can I simplify this? I can. Look at the numerator. Can I pull something out? X. X is a what? GCF. So pull out an X in the numerator. And what are we left with? X minus 2 all over X minus 2. And now do you see something that cancels? The X minus 2. So what's my answer? X. Okay, so what happened here? when I multiply the numerator and the denominator by the lowest common denominator, we're going to be able to cancel out those fractions. There's going to be some canceling going on. Okay, so we don't actually have to write this step. Alright, so let's look at example 2 and do it without writing this step and see what happens. Okay, so example 2. 3 over x squared all over 9 over x minus 3 over x squared. The denominator on the top is x squared, and we have two denominators on the bottom, x and x squared. So what is my LCD going to be?
3x squared.
Okay, does not have to be 3x. What can they all go into?
3.
They can all just go into x squared, right? X squared goes into x squared? X goes into x squared? And x squared goes into x squared? Yeah, so 3x squared can be a common denominator, but we want the lowest one, which is just x squared. So let's multiply the numerator by x squared, and let's multiply the denominator by x squared. If I multiply this numerator by x squared, what's going to happen?
We're going to get 3x squared over x to the 4th.
Why would I get x to the 4th? This is an x squared over 1. If I have x squared divided by x squared, what happens?
Cancels out.
These guys cancel. So what's in the numerator? Just a 3. We canceled out that fraction. What about this guy? I need to distribute it, right? So if I'm multiplying this first one by x squared, this x cancels with one of them, so what's left? 9x. Okay. Now I have x squared times negative 3 over x squared. What happens with the x squareds? They also cancel, so what am I left with? Minus 3. Okay, because this guy gets distributed. Okay, can I simplify? Yes. Ashley's like, yeah. What can I simplify?
3.
There's a GCF in the denominator, so let's factor out a 3, which leaves me with x minus what? I factored out a 3. 3x minus 1, and those 3's cancel. So what's left in the numerator? Okay, that's in the denominator. If there's nothing in the numerator, what's the placeholder? A1 all over 3x minus 1. Okay. Example 3. X over 2 all over 5x squared over 6 plus 2x squared over 3. Okay. Alright, so first thing we need to do is find the least common denominator. So I'm looking at all of my denominators, 2, 6, and 3. What's the smallest number that each of these go into evenly?
6.
Good, 6. So we multiply the numerator by 6, and we multiply the denominator by 6. Okay, so I multiply the top and bottom by the LCD, which is 6. And then let's simplify this. 6 times x over 2. Can we cancel anything? Yeah, 2 goes into 2 once, and 2 goes into 6 3 times. So our numerator is going to be 3x. All over. Okay, this 6 is getting distributed to both terms. Okay, so when I multiply 6 by this first term, what happens there? both 6's cancel, right? So it's just going to be 5x squared. Now, just because these 6's cancel, we still have to multiply 6 times the second one because we're distributing. So we can actually rewrite this, I guess, as saying this guy times 6 and this guy times 6 if you want, guys don't want to get confused. Are you okay with that?
That just confused me.
Because we're distributing, so this guy gets multiplied by 6 and this guy gets multiplied by 6. So what happens here? Do these cancel?
Yeah.
Yeah, 3 goes into 3 once and 3 goes into 6 twice. So what's left? Plus 4x squared. Okay, 3 goes into 6 twice, so we're still left with a 2 on here. 2x squared times 2 gives me 4x squared. So it doesn't cancel, it just reduces in this case. Okay, can I combine like terms?
Yeah.
Yes, so this is 3x over 9x squared. And can I reduce at all?
Yes.
I can. 3 and 9, what does that reduce to?
3.
3 goes into 3 once, and 3 goes into 9 3 times. And what about these x's? This x cancels with one of those. So what's left in the numerator? A 1 over 3x. Example 4. X squared over 10 minus 4 over 10 all over x over 5 minus 2 over 5. Think to yourself, what is the LCD? Alright, looking at all of my denominators here, what is the LCD? Good, 10. So let's multiply everything by 10. Lowest common denominator, which means 10 also has to go into it. We're not looking for the factor, we're looking for what both of them go into. 5 goes into 10 and 10 goes into 10, but 10 does not go into 5. Okay? And then we multiply each of these guys by 10. Okay, so we multiply everything by the LCD. Okay, what happens to this first one when I multiply by 10? The 10's cancel, so I'm left with x squared minus, what about these guys? 10's cancel, minus 4. All over. Okay, now what about these guys? Reduces to 2. So 2 times x gives me 2x minus, those guys cancel to 2 minus 4. So far so good?
Yeah.
Okay, good question. Was it Ashley that asked it? These first reduce, right?
Yeah.
No. Okay, hold on. Why do the 4s not reduce? Julia. Okay, they're attached by subtraction, not multiplication. So we need to factor these guys first. The numerator is difference of 2 squares, so that would be x plus 2 times x minus 2 all over, can this reduce? What's the GCF? 2. 2 times x minus 2. Are we done? X minus 2's cancel. So what's my answer? X plus 2 over 2. These 2's do not reduce because the numerator is addition, not multiplication. So you leave it like this. Okay?